Okay friends of class 11 science, continuing with our chapter of differentiation, we now do some differentiation with the trigonometric functions, the basic trigonometric functions sin theta, cos theta and tan theta. Okay, now the basic rule that is to be applied here is, this is rule number 1, that the differentiation of sin is equals to cos and the differentiation of cos is equals to minus sine. These two are the very basic derivations, differentiations of trigonometric functions. What is this? ddx of sin x is equals to cos x, where ddx of cos x is equals to minus sin x. Okay, these are the two basic rules for trigonometry, and now based upon this, can we find out? See, these two are to be learned by heart. Okay, from where does this differentiation come? That is the business of mathematicians. We are just going to apply these things over here. Clear? Okay, no need to bother about how these things are coming. We need to bother only about how these things are applied. Now, finding the ddx of 10x. How do we find the ddx of 10x? We have to use some basic rules of differentiation for this. First of all, instead of x I have written theta, but that does not make any difference because x and theta both represent variables. Okay, so now how do we carry on the differentiation? What is the first step? The first step is to write tan theta as sin theta over cos theta. So this is dd theta of tan theta. This is dd theta of sin theta over cos theta, which is similar to this. And now what we are going to do? We are going to apply working rules of differentiation. If you have two functions like this, u by v, and you want to find their differentiation of u divided by v. How is this carried out? It is given as v du over dx minus u dv over dx whole divided by v square. Now this is the thumb rule. You have to remember this whenever you want to carry out the differentiation of fractions. And now, based upon this rule, we will do the differentiation of tan theta. See, instead of u what you have? Sin theta. Instead of v what you have? Cos theta. Okay, so applying this to this, what do you get is this. First write down v as it is, that is, we write down cos theta as it is, and we take the differentiation of this. That means we are going to take the differentiation of sin theta, putting a negative sign, now writing u as it is. What is in place of u? It is sin theta. So this is sin theta written as it is, and now you have to carry out the differentiation of cos theta. Okay, now this entire term is divided by v square. Where is v? It's in the denominator. And what is the denominator? It is cos theta. So what we will write over here is cos square theta. Now, cos theta written as it is, cos theta written as it is. What is the differentiation of sin theta? Come back to the rule. Differentiation of sin theta is cos theta. So, instead of this, what I am writing over here is simply cos theta. Negative sign, copied as it is. Then sin theta, nothing is to be done for this sin theta. So, we write it as it is sin theta. And now, dd theta of cos theta, differentiation of cos theta. What is differentiation of cos theta? Come back to the rules. It is minus sin theta. Okay, so this is minus sin theta. Okay, now what happens? One thing more you have to do. Cos square theta is this entire term is to be divided with cos square theta. Okay, now what happens? Cos theta into cos theta becomes what? Cos square theta minus sin theta minus sine theta. This minus minus will change into plus. So plus sine theta into sine theta is sine square theta, and then divided by cos square theta. Now what is sine square theta plus cos square theta? It is equals to 1. 1 divided by cos square theta. What is 1 over cos square theta? Is sec square theta. This is the solution. So what is differentiation of tan function? It is sec square. Or what is ddx of tan theta? It is sec square theta. What is ddx of tan x? It is equal to sec square x. In the same way, you can find ddx of cot x. Then again you can find ddx of sec x. I will give you one hint on this. How do you find ddx of sec x? It is simply d dx of 1 upon cos x. And what is to be done from here? Simply apply this rule to this function. Instead of u, you will have 1. Instead of v, you will have cos x. Okay, there are a few questions given in the sheet. You will be required to solve those questions. So go ahead. This is all going to be funny and somewhat challenging also. Now we come to the major thing, that why do we use differentiation in physics? What is the use of differentiation in physics? You already know the word instantaneous. Okay. Whenever you want to find instantaneous things, you will need the help of differentiation. Got it? Now, okay. Let me put the question like this. There is a balloon. What is it? There is a balloon of radius r. Okay. Now what is the volume of this balloon? Volume of this balloon is basically, it is spherical. So volume of sphere is 4 by 3 pi r cube. And now the question asked to me is, what will be the change in the volume of balloon if the radius of balloon is changed? I am repeating the question. What will be the change in volume of the balloon if the radius of balloon is changed? How do we write it in the language of mathematics? Change in volume of balloon with respect to change in the radius. This is how we write it. Okay, now what is volume of the balloon? Volume of the balloon is 4 by 3 pi r cube. Now you are going to differentiate. The first thing to be done, take the constants outside. What is constant? 4 will be constant, 3 will be constant, and 5 will be constant. So better take these things out. 4, 3 and 5. Now what we are left with is differentiation of r raised to 3. How do you differentiate r raised to 3? And x to the power n minus 1, you know the rule, apply that rule. Constants are written as it is, 4 pi by 3, and the differentiation of this is 3 r square. Got it? So 3 cancels out. What remains is 4 pi r square. Okay, what does this answer mean? This answer means that if you change the radius by a very small quantity, the volume changes by this quantity. Suppose if the change in radius, I can write it as delta r, or I can write it as dr. If dr is equals to 0.001 meter, what is the change in volume? The change in volume is 4 pi. Change in volume is equals to 4 pi into 0.001 square times. This is the change in volume. Okay. Now, suppose I have a circle. Okay. This is not a sphere now. What this is now? This is a circle, and the area of circle. Area of circle is pi r square. And now the question given to me is if the radius is changing by small amount, what will be the change in area? If radius is changing by small amount, what will be the change in area? How do we write it? We write it like this: change in area with respect to change in radius. Again, change in area with respect to change in radius. Okay, put the values. Differentiation, ddr. What is area? Area is pi r square. What is constant? Pi is constant, so pi comes out. What is left? Differentiation of r square. What is differentiation of r square? Pi as it is. Differentiation of r square is 2r. So what is the answer? It's 2 pi r. Got it? So if radius changes by amount r, the area of the circle changes by the amount 2 pi r. This is how we apply differentiation in finding various changes. There are again many examples based on this, but this is how you are supposed to proceed. And now coming to the motion, how do we apply differentiation in motion? You have to hear the question properly. Suppose that the distance covered by an object, what's the distance covered by an object, is equals to 3 plus 2t plus t square. Distance covered by the object is depending on time, and this is that equation. And now I am finding two things from this. One is the speed and other is acceleration. Okay, how do I find speed? Basically the formula to find speed is s by t, distance by time. But because I have an equation over here, if I had been given some numbers, 1, 2, 3, 4, 5, 6, 7, 8, 100, 200, whatever. If I would have given some numbers, then I would have simply go for the division. But numbers are not given to me. What is given is an equation. So here also I cannot use division. I will be using differentiation. Instead of s by t, I will be writing ds by dt. And now what should be done? Differentiate this. That means carry out the differentiation of 3 plus 2t plus t square. How do we do that? d by dt of 3 plus d by dt of 2t plus d by dt of t square. Okay, what is differentiation of this? 3. There is a constant, the differentiation becomes 0. Here 2 comes out because 2 is constant, and what is left? It is simply dt by dt plus t square. What is differentiation of t square? It is 2t. Okay, 2t, dt cancels out. What is remaining? 2 plus 2t. It is 2 plus 2t. This is what? This is the velocity or the speed of the particle. Now finding the acceleration. How do you find the acceleration? By the definition, acceleration is defined as rate of change of velocity. That means acceleration is change in velocity upon time. But again, velocity is in form of an equation. If it would have been in form of numbers, division was very good idea. But you cannot divide the things over here. Okay, what you have to carry out? Equation, carry differentiation. So, what we are going to do? We are going to differentiate velocity with time. So, it is d over dt of 2 plus 2t. 2 plus 2t. Carry out the differentiation d by dt of 2 plus d by dt of 2t. This becomes 0. Why does it become 0? Because 2 is constant. Derivation of constant is 0. And d by dt of 2t. plus 2 comes out, what remains is dt by dt cancels out. What the answer is 2. So what is the velocity? Velocity is 2 plus 2t, and what is acceleration? Acceleration in magnitude is equals to 2. Clear with this? Now, suppose in this way you are finding the velocities and accelerations, and if the acceleration comes out to be 0, see, if you carry on this mathematics and you find acceleration equals to 0, that means the body is not increasing the speed, the body is not decreasing the speed, the body is continuing with the same speed. That means the motion is uniform motion. Okay. Now, if speed of the body is equals to 0, very simple, if the speed of body is equals to 0, the body is at rest. Okay. If you find that acceleration is greater than 0, acceleration is greater than 0, then the body is actually increasing the speed. This will be acceleration, and if the acceleration is to be found less than 0, then it is what? Then it is retardation. Retardation means the speed of the body is decreasing. Okay, these things should be nail these things in your brain, because every now and then you will be requiring it. Let us go for some more examples. Say the distance covered by the body. The distance covered by the body is simply given as 2t. Okay, it's 2t plus half, we have some constant, say 4. This is distance covered. How to find velocity? ds over dt. Okay, now differentiate this. d by dt of 2t plus d by dt of 4 is equal to, what is d by dt of 4? Equals to 0. 4 is constant. What is this? 2 comes out. What remains is dt over dt. This cancels out. What is this? It is 2. Speed of the body is equals to 2. And now the acceleration. Acceleration of, what is acceleration? It is dv by dt. Now taking the differentiation of this, what is v equals to? V equals to 2. So this is d over dt of 2. 2 is constant. Answer is what? 0. That means acceleration is 0. That means what the motion? The motion is uniform motion. Okay. Now let's come to this. It's the distance covered by the body is minus t square. Distance covered by the body is minus t square. What will be this? You are supposed to find the acceleration or retardation. First we find the velocity. Velocity equals to ds over dt. Okay, minus sign outside. d by dt of t square. Minus sign as it is. What is t square? T square is 2t. This is what? This is velocity. Now finding the acceleration. What is acceleration? dv by dt. That is d by dt of minus 2t. What is constant? Minus 2t is constant. What is left is, sorry, minus 2 is constant. Minus 2 is constant. Minus 2, and this is dt over dt. Cancel this out. What is acceleration? Acceleration is equals to minus 2. You can see acceleration is less than 0. So if acceleration is less than 0, what this is? This is retardation. Okay. This will make very clear in your mind that what is the need of differentiation in physics. There are few exercises given to you, and you are supposed to do those exercises as many as possible, and in case of doubts you have to inform me. But remember, you cannot move further in physics unless and until you have a mastery on this topic.